Yes, hello and welcome to today's class. So we shall be handling a new topic, and that is integration, which basically is the reverse process of differentiation. So in this particular example, we have three derived functions. That is, for A, we have the derived function dy dx being equal to 3x squared, and for the second term function, we are having 4x cubed being equal dy dx being equal to 4x cubed, and for the third function there we're having that the derived function dy dx is equal to x cubed. And so we are supposed to perform integration to this derived function and find the original function, that is the value of y. All right, okay, so basically it's the reverse process of differentiation. So to do that, we're going to have that the value of y, which we are trying to find here, is actually equal to 3x, okay, raised to 2, and whatever we have in the power, we add 1 to it, plus 1, and we add a constant to the polynomial y. And the reason why we do that is because we believe that the function of y has a y-intercept. Okay, it has a place of where it intersects. This covers a place where it intersects with the y-axis in the Cartesian plane, and so that is what we call the y-intercept. And so that is why we add this c, as we do not know at this particular moment the value of c, so we have it there as a constant. All right, so then we divide the whole term, that is the term that we're trying to find its integral value, by the sum, that is 2 plus 1, the sum of whatever we'll get in the index. So we do not divide c by it, we just divide the term that we've actually performed the integration to. All right, so then notice that our value for y will be equal to 3, okay, x 2 plus 1 will be 3, and then 2 plus 1 on the other, on the denominator, will be 3, okay, all of it divide by all of it plus the y-intercept that we are given by a constant c. So we can simplify and find that the value of y in this particular case will be, okay, dividing by 3 divided by 3 will be x cubed plus c. And so that is the integral function of dy dx, okay, for the first problem, that is 3x squared. So our y will be x cubed plus c, and that is it, given that this is actually an indefinite integral function. So we go on and solve for b. We'll follow the same thing, same methodology. So for us to find the value of y in this derived function, y will be given by, all right, 4, okay, x, whatever we have in the index, plus 1, that is 3 plus 1, and then we divide the whole thing by 3 plus 1. So, okay, and then we add c for the y-intercept, which at this particular case I've said we are not able to tell what value it holds, as this is an indefinite function, integral function. All right, so then we go ahead and simplify to find the value of y, and it will be 4, okay, x 3 plus 1 will be 4, so it will be 4x raised to 4 all over 3 plus 1, of course, that is 4 plus c. And so you notice that our value for y will be, when you divide 4 by 4 here, our value for y will be x raised to 4 plus c, and that will be our integral function for our second problem. All right, okay, so for the last problem, we are then going to have that the value of y equals to x, okay, cubed plus 1, of course, whatever we have in the index plus 1, of course, plus the y-intercept, which in this particular case we given to be c, and of course remember that we're supposed to divide this by 3 plus 1, okay, the sum of whatever we got in the index. Okay, so our value for y will be equal to x raised to 4 all over 3 plus 1 as the denominator raised to 4, okay, plus c. And given that there is no any common factor between this term, we'll just leave our answer there. And so this will be our value for y in the third problem. It will be x raised to 4 all over 4 plus c. So that is it for this particular class. In the next class, we shall handle integration of derived functions that have more than one term so that you are more familiar with it. Thank you and see you in the next one.